Hello, I'm Brian Farrell, and welcome to PACE IT's session on the Introduction to the CPU. Today we're going to discuss CPU basics, Intel and AMD CPUs, and then we'll try and answer the question of which one is right for you. Now with that, let's go ahead and begin this session. So let's begin with some of the basics of the CPU. According to Moore's law, the number of transistors on an integrated circuit will double approximately every 2 years. This creates an exponential growth in the power of the integrated circuit. Now, Moore's law was introduced back in the 60s, and it still pretty much holds true for today's CPUs. So now let's talk about the central processing unit, the CPU. The first characteristic of it is speed. Now, speed typically is the frequency at which one core of the CPU operates. Currently, it's measured in gigahertz per second. The higher the number, the faster the core. Now, let's talk about the cores. Now, the cores are the actual CPU on a chip, on a silicon wafer. If a CPU is a multi-core CPU, then it actually has multiple CPUs on the same chip. The more cores, the more simultaneous tasks that can be accomplished. Then there's cache. Cache is expensive static random access memory that is located on the CPU die. All cache memory is much more expensive than regular dynamic random access memory, so not much of it is used. Cache is broken into 3 levels. L1 cache is typically embedded in each core of the CPU. L2 cache is typically located just off of the CPU or embedded into a coprocessor. L3 cache is still on the CPU die, but it's a little bit slower than L1 or L2 cache. Now let's move on to hyperthreading. Hyperthreading is the logical division of a CPU core. Through special instruction sets, the CPU is made to look and behave as if it had more than a single core. So you could have a 2-core processor that had hyperthreading, and it would actually behave like it was a 4-core processor. Some CPUs have virtualization support. When virtualization began, it always required fairly complex software and a host operating system. CPU manufacturers have now built virtualization support into some of their processors. This allows for easier and less complex virtualization. Some more modern CPUs are now coming with a GPU, a graphics processing unit, on the die. This allows for decent integrated graphics performance while not hindering the basic operation of the CPU. So you don't have to buy a graphics card and your CPU performance is not hindered by graphics rendering. Last but not least under the CPU basics is the architecture. Now this is either 32-bit or 64-bit. This deals with the amount of memory that a CPU can address, that is, keep track of. A CPU that has a 32-bit architecture can only address a maximum of 4 gigabytes of RAM, while a CPU that has a 64-bit architecture can address a theoretical maximum of 16.8 million terabytes of RAM. Man, that is just a ton of RAM. In actuality, the maximum amount of RAM that a 64-bit system can handle is established by the motherboard manufacturer. And before we leave CPU basics, let's talk about cooling. As a rule, the higher the performance of the CPU, the more heat it will generate. Excessive heat will kill or burn out a CPU. Heat is your enemy. To combat that, there are heat sinks. A heatsink is a device that is placed on top of the CPU. It usually has a solid metal base, but it transitions to fins towards the top. A heatsink will draw heat away from the surface of the CPU towards the top of the sink where it is radiated away into the case. To help improve the efficiency of the heatsink, we use thermal paste. It's a special compound that is used between the CPU and the heatsink. It fills in the microscopic voids that are present and will improve the connection between the heatsink and the CPU, thus improving the heatsink's performance. Fans are used to help radiate the heat away from the heatsink. They are designed to draw cooler air across the fins, thus transferring the heat away from it. And finally, there's liquid-based cooling. This works kind of like a car's radiator. The heatsink actually has liquid being pumped through it to draw heat away from the CPU. The liquid gets pumped to a radiator where the heat is dissipated. Now let's move on to Intel and AMD CPUs. We're going to start with Intel because they're the granddaddy. Intel currently uses Land Grid Array CPUs, LGA CPUs. The CPU does not have pins on the bottom of the chip. The pins are actually located in the CPU socket on the motherboard. The CPU just has corresponding contact points on the bottom of the processor. Intel processors are usually defined by their processor family, like Haswell or Ivy Trail, and their socket type. Some Intel socket types are the LGA 775, the LGA 1155, the LGA 1156, and the LGA 1366. There are many more Intel socket types, and more are being introduced all the time. Now let's move on to Intel's main competitor, AMD. Most AMD CPUs are pin grid array CPUs, PGA CPUs. The CPU has pins on the bottom that fit into holes on the socket. AMD's naming convention is also based on processor family and socket type as well. Some AMD socket types that you'll see are the 940, the AM2, the AM2 Plus, the AM3, the AM3 Plus, the FM1, and the F. As with Intel, this is not a comprehensive listing, plus there are more being created all the time. So let's talk about which one is right for you. Well, I can't really answer that question. The key to determining the correct CPU for you is research. Now, when you're researching the purchase of a CPU, you need to consider what you are trying to achieve, as well as any budgetary constraints. As a rule, the better the performance of the CPU, the more it will cost. And the newer the processor family is, the more it will cost. Also, in most situations, the software that is available today can't take advantage of the full capabilities of the CPU. So you may not want to buy the most cutting-edge current version. But as the processor's performance increases, they develop software to take advantage of more and more of those capabilities. So which CPU is right for you? I can't answer that for you. You're going to have to be the one to do the research. Now that concludes this session on the introduction to the CPU. We covered quite a few CPU basics. We talked briefly about Intel and AMD CPUs, and then I tried to answer the question of which CPU is right for you. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure you'll watch another one soon.